should actually start from here. What are the problems with fixed effect LSDV models? Right? So, first problem is you might run up against the degree of freedom. What do I mean by that? Because in our, data set, we had only 6 companies. So we are concerned about 6 dummies, and in fact, 5 dummies and 1 intercept. But if you have 500, cross-sectional units, what do? Will you include 499 dummies in your model? So
Not
it is going to be a challenge, right? Yes or no?
Yes, sir.
So it is practically, very, very, difficult to incorporate that sort of a model, and reporting that model in a research paper is going to be even more challenging, right? And it is something quite common that you work on 500, companies, 500 farms, very much possible. So it could be a problem. The second problem is when you have too many dummy variables in the model as regression, even if you do not use, say, interactive or multiplicative terms. What do I mean by that? You multiply the dummies with some of the, uh, regression. Even if you do not do that, if you have too many dummies in the model, and these dummies being the individual fixed effects are expected to correlate with the other regressors, right? So that can also lead to a problem which is called multicollinearity, right? So if they are in the error term, then they create a problem of, the exogeneity assumption gets violated. But if they are in the model, then they can create multicollinearity problem, right? Yes or no? Then, one of the assumptions that, the individual regressors should not be correlated among them. At least strong correlation should not be there. And we deal with that problem. If that they are strongly correlated, then we use some kind of PCA technique. Using PCA technique, we kind of club them together. Highly correlated variables are clubbed together, and then we run the regression. So if they're in the error term, then also it is a problem. If they are in the main model, then also it can be a problem. Is this point clear to everyone? Yes or no?
Yes, sir.
Yes, sir. Yes, sir.
Yes,
Yes.
sir.
So if they are in the error term, then it can lead to violation of exogeneity assumption, which says that your regressors and error terms should not be correlated. But if they are in the model, then they might create multicollinearity problem, which says that regressors should not be strongly correlated among them, right? Even though multicollinearity is a less severe problem than the violation of exogeneity, but still it could be a challenge because you'll have to take care of that problem if it is there, right? So these are the two main problems in fixed effect with these dummy variables, right? So what do you do to overcome this problem? To overcome this problem, we have a model called fixed effect within group estimator model, right? And in fact, when we talk about fixed effect model, we basically refer to this model. For all practical purposes, we do not use that least square dummy variable approach. What we use is this method, that is the fixed effect within group estimator, right? So what do? You need to recognize the fact that there are fixed effects, individual company specific fixed effects. You need to recognize that fact. So you bring them into the model. That's fine. But if you bring them into the model, it creates additional problem, as I just explained. So ideally, you have to get rid of them. How do you get rid of them? What you do, you just simply from each variable for each company, you calculate the mean and you deduct the mean from each variable. You do it for all the companies, right? And on the d-mean values, you run the regression. So you might say that then what is the fun? Why are we complicating life unnecessarily? By doing so, we are achieving one very, very important objective. We are getting rid of the alpha i's that we have included in the model. Why? Because since these are time invariant, what is the mean of a variable which is time invariant? That variable itself, yes or no?
Yes, sir.
So if I demean each variable, each observation, what will happen? This fixed effect which automatically will be removed. Yes or no?
Yes, sir.
Yes.
Time in. Yeah.
So if that happens, then I achieve two things. I considered those fixed effects in the model, but I actually remove them. And you will be, astonished to know that the estimate that we will get from this model will be exactly same as the estimate that we got from the dummy variable approach, right? But this model does not suffer from the problem that the dummy variable approach model suffer, right? So this is the beauty of this fixed effect within group estimation model. Now you might ask me, sir, why is it called fixed effect within group estimation? Where from this concept of within group comes? Can anyone explain or throw some light on this?
Yes, sir.
I hope this process is clear. What is meant by demeaning, right? And why do we do so? Because we want to get rid of the fixed effect component from the model, right? Now, please try if someone wants to, try. Why is it called within group?
So because we are calculating mean for each company and we are demeaning the data. We are calculating the difference from the mean within the group. So within each company.
What do you mean by group here?
Sir, one company, one firm.
Yes. Here, group means that individual company or the firm or the country or whatever is the cross-sectional unit. That is the group. So basically, what you are doing is you are looking for variation within the group, right? Because you are deducting the mean of each variable for each company from each observation of that particular company. So what is left out after demeaning? That is nothing but variation within the group. Yes or no? Within that particular company. Correct?
Yeah.
Is this point clear?
Yes.
Is this point clear? And hence the name within group. There is one more version where we say fixed effect between group. In that case, what we do? Each individual observation from that particular observation, we deduct what? The average of all the groups. That is all the individual companies. That is called fixed effect between group, but which is not a very, very popular, approach. Generally, it is not used. This one is used. So fixed effect within group model, right? So mathematically speaking, if I do the demeaning part, and if we note, or if you use the notation that is TC, small tc it, small q it, pf it, and if it, if we represent them as the mean corrected values or d-mean values, then we can rewrite the model in this way. And you see, in this model, there is no intercept. Why there is no intercept in this model? Anyone? In this model, there is no intercept. Why there is no intercept in this model?
You have removed the fixed effect.
Yes, because those intercepts were, time invariant. So when we do the demeaning, they are removed from the model. Okay, fine. So what we have achieved by doing this? First, we brought the time fixed effects from this U into the model, and then we demeaned it and got them removed from the model, right? So this is what basically we have done, and this is the crux of fixed effect within group model. Okay, I hope this is clear. Now what we'll do, we'll just go to R and estimate the model. Yes. Any question anyone has?
Yes, sir. Sir, as you said, the least square method, there the problem was, first was we may run out of degree of freedom, and second was the multicollinearity. Because of that, we have come to this within
Yes.
groups. And here we are removing the constant.
Yes, yes. all time invariant variables will be removed. Okay.
Okay. So
Fine.
when we, what does this mean? Where is this mean coming from? I'm a bit confused.
Mean is nothing but, see, for example, if you have airlines one, it has a total cost numbers are available. You just simply calculate the average of that, right?
Yes, sir.
And that that average is deducted from each observation. That is called demeaning.
Okay, got it.
Yeah.
So this removes problems like multicollinearity.
No. This will remove the fixed effect that alpha I from the model. If alpha I is removed from the model, because alpha I is creating the multicollinearity in the model. So if that is removed, then that multicollinearity problem will also be removed, right?
So even alpha creates multicollinearity.
Yes, it will create. Now, what is alpha? Alpha I is what? That is individual company specific effects. Yes or no?
Yes, sir.
Right. So for that only we use dummy, correct? And
Okay.
those are expected to be correlated with the other regression,
Okay.
right? So you need to get rid of them from the model.
Okay.
Is it clear now?
Yes, sir.
Okay. So let us proceed now and we will do
Sir,
the
sir, is there any intuition behind using T into CI? Why this kind of multiplicative term means? Is there any intuition behind taking this?
which one?
The last slide you showed the equation
Yes.
T into CI.
No, this is just a notation that they have used. Instead of
Okay.
C, they have used total cost.
Okay. Sorry. Oh, okay.
It has got nothing to do with the time component or anything of that.
Okay. Fine. Okay.
Instead of writing only C, they have written total cost as TC. That's it. Nothing else.
Okay.
This is nothing else. Okay. So I think basic idea behind this model and why we do what we do is clear, I think, for everyone. Yes or no?
Yes,
Can
sir.
I now go to R and definition? Yeah. Okay. So let us go to R and do the estimation. Okay. So please open your R Studio, everyone, and let us do the things from the very scratch. And those who are joined today only, so not to worry, we will just go a little slow for next 10-15 minutes and then we'll pick up the speed. So let us now talk about today's codes. Where is the starting point for me? Yeah, we'll start from this point. R script for 20th December. Okay. So if you open your R Studio and if you find that your environment is crowded, then please use this Jharu to get it cleaned. Okay. Please get it cleaned. That might create problem. Too many backlogs might create problem. You use this, this symbol to get it cleaned. Okay. Fine. Now, first thing first. First, you have to set the working directory. Every time you start, you have to set the working directory. Now, how to set the working directory using menu-driven thing? Please do it, everyone. Session, set working directory, choose directory, and I told you to create one folder in the desktop. Right? What is that name of the folder? FDP_panel. And in that folder, you are supposed to keep the data set, right? So then you click open, right? So here you can see your directory is set, right? And if you do not want to do the menu-driven thing, then you can use this command to set the directory, right? So that is what I have done here. Because once you have set the directory and if you have copied this command, for next day onwards, you do not have to do the things manually. You can just simply click on this and your working directory will be set. Okay. Is this process clear to everyone?
Can you please repeat the step
I
of the
will just
working directory?
go to session. Okay. First of all, have you created one folder in the desktop named FDP_panel? First do that.
Yes.
First create one folder in the desktop. Name of the folder should be FDP_panel. And within that folder, you have to put the data set that I had shared yesterday in the group. Do you have that data set with you? Yes? No? So first go to session, then set working directory, then choose directory. Then select the folder that you have created and click open, right? So it does not really matter.
Yes,
You
sir.
can do it.
Thank you so
multiple times.
much. Yes.
Is it done now?
Yes. Thank you.
Yes. Okay. And then, you can also use this code get working directory to, see the path where your working directory is located. So if you click on this, it will show you the path. You see, this is the path where the working directory is located. This is the path where the working directory is located. Okay. This is just an optional thing if you want to check. Then next step is to import the data. For importing data, you have to install the package called readxl, right? Those who installed the package yesterday, you need not install it again. You can just simply call that package. But those who are doing it for the first time, please do it. Install.packages. How to install? Install.packages. Within bracket, double quotes, and within double quote, you have to write readxl. Install.packages. I'm just showing it once more for those who have joined today. Install.packages. Once you start typing, this will, pop up. You just click tab, it will come with this, bracket, and then you use this double quote and then type readxl. Okay. So please do it and install it. Install.packages, readxl. Just run this. Even if you have done it once, not an issue. And once it gets installed, then you have to click on library readxl. Library within bracket readxl, but this time you need not put the double inverted comma, right? So run. That means now you are ready to use this particular package, right? And then you have to read the data. How to read the data? This is the command for that. Data is equal to read_xl. So I'll just show it once for those who are doing it for the first time. This part is done. Now we will just run this code. Okay. So are you able to get the data into your environment, everyone? Yes or no?
Sir.
What is the next thing that we need to do? We need to run this package called CLM, right? And yesterday, if you have already downloaded or installed it, today you need not do it again. But those who have not done it, please run this. and then you run the library. Up to this, everyone could do? Yes or no? Install.packages PLM and library PLM. Up to this, everyone could do? Yes?
Done, sir.
Please confirm.
Yes, sir. Yes, sir.
Yes, okay. Next. What is the next step that you have to do? You have to convert or you have to declare the data as panel data. So for that, this is the command. So let me just give you the command in the chat or in the WhatsApp group so that everyone can take it from there. Okay. So this is the command for declaring the data as panel data. Once you have done this, then you are in a position to run the model, right?
Sir, it is only for those who have not done it yesterday, no, sir, because when we opened this,
you need to do this today also, because every time you
oh my God, okay.
start the R scripts, these
Okay.
have to be done. Okay.
Oh,
That means you have to set the working directory. All these things have to be done.
okay, sir,
So
okay.
what I'll just give all these codes in the WhatsApp group. You just quickly run all this. Okay.
Yeah.
Please do that. Or if you have the codes, yesterday's codes with you, you
Yes.
can copy
Okay.
there from those things and paste it for today. So you follow the style that I am following here. You give these dates like this and maintain your scripts, right?
Okay.
The similar things can be used, right? Just by minor modifications, correct? So that will save a lot of time, right?
So we'll have to start with install package and
Yeah. So set the working directory first.
yeah,
And
then
then,
that's done, sir.
yeah, that's done. Then install this package, read Excel. Then this command, library read Excel. Then read the data. Data is equal to read Excel, this one. And then install the package PLM. And then call that package PLM. Please confirm everyone has completed up to this. And once
I
this
have a
is done,
question.
yeah, tell.
Can you run the codes in one time? This if you select all and then you run it?
Yes, you can run one time.
Okay.
You can see, you can run everything in one go. That is also fine. That's not a problem. You can do that. Are you facing any issues with that?
No, sir. I just run them one by one, but I just thought maybe is it possible to do it
Yeah,
in
it is possible to run them in one go, because if you have this hash symbol before the text, then R will understand that that is not a code, that is a comment, right? So even if you select both a code and a comment together and run, R will run only the code, not the comment, provided you have given hash symbol before the text. That's it, right?
yes.
I hope this is
Thank you.
clear, right?
Yes, sir.
And
Mhm.
and then you declare your data as the panel data. This is the code, right? And now we have to run the model. Till this point, everyone could do it, right? Yes or no? Please make
Yes,
sure
sir.
that you have done this. Otherwise, the next steps you cannot follow at all, right? Yes or no? Please respond. You have
Yes,
done
sir.
it?
Yes, sir.
Okay,
Yes, sir.
fine.
Yes.
No issues. Now, now we will start with estimating the fixed effect within group model, right? How to go about it? I have named the model. So this is the code. This is the code. So let me just put it in the these two. We'll put it quickly in the group so that you can take it. And I requested everyone to be connected with WhatsApp wave. right? So that helps a lot because it saves a lot of time, right? So please do this coding part and then I will explain what this code means. Yes, coding part is done.
Yes, sir.
Yeah. So let me run the first code and also run the second code. Okay. So let us understand what is this first code. FEWG stands for fixed effect within group. You can give any name of your choice. This is not a problem, right? And as I told you, this symbol works similar way as the equal sign symbol. You can use any of either this one or equal sign. PLM is the function that comes from that, PLM package. C is your dependent variable, right? And Q, CF, and LF, these are your independent variables, correct? And data is equal to P data, comma, model is equal to within. Model is equal to within. Now you might be wondering, sir, here though you are not giving the dmin values, right? You are giving the raw information, raw names, that is C, Q, PF, and LF. But will it run the way you showed in the slide? What is the answer? Yes or no?
Yes, because you have
Why?
written model is equal to within.
Yes, absolutely correct. Because once I say within, it will automatically do that demeaning process and throw the estimates. Is that point clear? Yes or no?
Yes, sir.
Yeah, very good. Now you run this model, you get the output, and then you click on this summary. So that gives you the output, right? So this is the basic, model. And now you can just export these results to Excel sheet the way we did it last class. So just copy it. I'll just put it in the group for taking the result to Excel sheet. Taking the result to the Excel sheet, right? So do that. Please complete, everyone. First, I am just creating one subset of data for coefficients. Run this. And then I am taking the coefficients to one CSV file. And I have named them coefficient underscore FEWG. This name is up to you, any name you can give, right? As I told you last class, right? And if you have created the working directory, by default, it will get saved there, right? And if you do not create working directory, it generally gets saved in the documents, right? But I strongly recommend that you always create the working directory, okay? So you have,
So you have named this coefficient. We can give any name, right?
yeah, any name you can give, right?
Okay.
You can
And
give
then
any
you have
name.
$ coefficient. What does that mean?
This one,
Yeah.
because it basically means under summary of this model, you have lot many other things also other than the coefficient, right? You only want the coefficient, that's why. Okay.
Okay.
Yes or no? Got
Okay.
it?
And the next code says to convert it into a CSV file.
Yes, you are exporting those coefficients to the CSV file. That's it. Okay.
So can you please side by side open this CSV file?
I'll do that. Everyone has done this. Okay. Now I will just go there and see this is the file name, coefficient FEWG, right? Yes or no? Okay. Correct? Yes or no?
Yes,
Are you getting these same numbers?
Yes, sir. Yes, sir.
Yes, sir.
Yeah. And you see, these numbers are exactly same as, these estimates are exactly same as what we got using that least square dummy variable method. Yes or no? The same numbers, right? For Q, PF, and LF. All these numbers are same. So basically, effectively speaking, my main variables, the main coefficients of my main independent variables are the same, right? And this is much more efficient way of doing the modeling the relationship, right? Because we could kind of remove that problem that was created because of that fixed effects being inside the model, right?
So if
Yes or no? Is it clear?
this perfect is this model perfect? Because
So
it
that so we have to do diagnostic test, but this is better than that what do you call that approach of LSDB, because many of the practical challenges that we have with LSDB will not be there in this model, right? Okay.
because this model has R square of 0.9. So I thought, I mean, still spurious, or is it okay? We'll study that later.
That so anyway we have to do it using the diagnostic,
Okay.
right?
Sir,
But this is what I'm saying is this is
We are learning the
generating the
techniques,
same
right?
output,
Yeah.
but those practical problems that were there with the LSDB model are not there in this model. That's what I mean to say.
Yes,
Okay.
understood.
sir,
Yeah.
I have a question.
Yes, please.
Sir, alpha in this panel data is a composite error term wherein one is the constant value and the other one is the unobserved heterogeneity. So yesterday we
No,
discussed about
not in this case.
okay. Because
No,
sir, even in alpha, the time invariant, that means the unobserved
you are mixing it up with random effect model. I'll come to that. That is a different thing. Okay. So what we discussed yesterday, that if you do not include the fixed effect model in your main model, then they sit in the error term, and how that can create autocorrelation problem. There I explained that part, right?
right.
And that is not the same case as what we are doing here. Is it not?
But sir,
Here, so anyway, those alphas are removed from the model, right?
right. So, but it got completely removed, but the constant term.
Constant term will not be there because that's what I explained in this part, in the PPT.
Right, sir, I got your point because of this
Yeah.
time invariant factor.
Yes.
So, because we demeaned the data, but
Yeah.
still some
Yeah, tell what is the doubt? Hello?
Sir, yeah, I was thinking that still the constant should be there because I mean,
No, constant cannot be there because I ran the regression on the demean values, right? So when I demean, constants are already removed, right?
right.
So how come it will be there? It won't be there, right? Yes or no? Is it clear?
Right.
Okay. So I think I just have closed the PPT again. Let me just see where the PPT is. Okay. So now let us come to that output model, output slide, right? Okay. So this was the model. See, now in this model, can you see, do we have the intercept term anywhere in this model? No, right?
No,
No.
sir.
It should not be there because I have demeaned, right? So those intercepts will be removed, correct? Because those intercepts, when we treat them as fixed
Yeah,
effect,
sir, I got it. I got it, sir. I got it.
they are time invariant. So
Right,
after
sir.
demeaning, they will be removed from the model, right?
Got it, sir. Got it.
Again. And you see that this table 2 shows the model output of that least square dummy variable approach. Table 3 shows the model output for the fixed effect within group model. And Q, PF, and LF. Just see the numbers Q, PF, LF. These numbers are exactly same, right? Yes or no? They are exactly same. Fine. Correct. And this model does not have the problems that are there with this least square dummy variable approach. Practical problems that are there. So very tactfully, we have removed those practical problems, even though we are getting the same result, right? And this is this model, this table 1 and table 3, right? This compares. What is this table 1? Table 1 shows you the output of the OLS, pooled OLS model, right? Correct. The first one, that what we did, correct? And how this 3 and 1 are different. Please understand, in pooled OLS also we did not include, that also did not have the fixed effect within the model. And this within group also, when we run the regression, did not have the fixed effect in the model. But they are significantly, results are significantly different. Why? Because in OLS, pooled OLS, we did not recognize the fact that there are individual specific, fixed effects. But in fixed effect within group model, we first recognize them in the model, and then in the estimation process through demeaning, we remove them. So though we remove them in model 3 or in table 3, that is the fixed effect within group model, we recognize the fixed effect. Hence, it is still called a fixed effect model, right? But in table 1, which is capturing the pooled OLS regression output, there we did not recognize the fixed effect. Is this point clear to everyone? Yes or no? Is it clear?
Yes,
Okay.
sir. Yes, sir.
So let us now proceed. Since it is clear to everyone, so let us now proceed. Now let us talk about what are the disadvantages of this approach. And by and large, when we talk about fixed effect model, this is the model that we talk about, right? Not the LSDB model. I told you why that is not used generally. This model is used, but it has got some limitations, right? What are the limitations that it might have? Anyone? The first thing that we are talking about, if you do the estimation with the help of d-mean data, then you have to sacrifice something. What is the sacrifice that you make? Just to remove the fixed effects from the model, invariably you will end up removing all the variables which are time invariant. Yes or no? So there are other variables also that might be important for modeling purpose, but they are time invariant in nature, right? Those variables will also get removed. Say, for example, gender, right? Time invariant, right? Yes or no? Different types of companies, say public sector company, private sector company. These are also variables, categorical variables, which can have impact on the dependent variable. But if they are time invariant, and if you run this fixed effect within group model, they will be removed from the model, right? So this is the price that you have to pay to avoid the correlation between error term and the explanatory variables. Then what is the way out? Can we do something about it? Say, for example, let me give you another example, not with relation to this particular data, but because in this particular data, we do not have any time invariant variable other than that fixed effects. Say, for example, I am working on bank, right? As I was telling you the other day, impact of bank ESG practices on the profitability. In fact, I would like to share one good news with all of you. Yesterday evening only, I got one email from the editor of the journal where I sent the paper that it has been like not yet accepted, but they are ready to kind of publish our work, and it's a category journal, right? So with some modifications, we'll have to send the revised file. So it is going to be accepted, right? So, and that was a work on impact of ESG practices on firms' default risk. That is also again on banks, right? So in banks, when I'm talking about banks, in India, we have public sector bank and private sector bank, right? Yes or no? And don't you think that will impact the different nature of banks will impact their performance? Answer is yes. But if you run this fixed effect model within group fixed effect model, those variables cannot be incorporated directly in the model because it will be removed, right? Yes or no? Did you get what I just said? Yes,
Yes,
or
sir.
no?
Yes. Yes, sir.
So then what is the way out? If you are using this model, then you are losing out a significant part because any industry type or any categorical variable that may have impact on the dependent variable will be removed because of the demeaning process. Then what is the solution? Anyone? What is the solution? The solution is doing the analysis based on subsamples, right? So what we will do, we cannot directly include them in the model, but we can always do the analysis based on sample. We'll create one sample for private sector bank. We'll create one sample for private sector bank and run the model. And then we will see if there is any difference in the result. So that is possible, correct? So though this is a problem, but indirectly we can address that problem. Is this point clear to everyone? Yes or no? First point, and how to address this issue.
So if we classify the banks in like private and public sector banks, then how it will be a panel? Like I'm not getting the
No,
point.
why not? Why not panel? In private sector, suppose in India, as of now, I think 36 banks are listed in stock exchange.
Yes,
Out
sir.
of that, 12 banks are public sector banks.
Yes,
right?
sir. Just public. Yes, sir.
So 12 banks for 10 years data if I have, it's a panel, right? And
Yes.
say another 20 banks or 23 banks, 24 banks, private sector banks. That is also a panel, right? For 10 years data, correct? So
Then
I can
yes.
Divide my complete sample into 2 samples and run the model and see whether there is heterogeneity in the result or not. So we can do it like that, but it will require you to do subsample analysis.
Yes, sir. But
So
then
first,
you will not get the aggregate impact, sir. The aggregate impact of the overall banking industry you will not get. Like you will be doing a
no, we will get it. One will be the aggregate impact. One will be the impact on say one of the subsamples, means 2 subsamples. So one analysis for total, taking all the banks together. One analysis for only private sector bank. One analysis for public sector bank. Right?
Then overall model will have categorical variables. Then how will you demean them?
No. Overall model won't have categorical variable, right? And that is the limitation. Just to overcome that limitation, we divide the sample into 2 subsamples.
Okay,
and
sir.
run the model and see whether the difference is there any difference in the subsamples or not. Okay.
Okay,
so
sir.
indirectly we can take the sectoral heterogeneity into our analysis. That is called
Yes.
sectoral heterogeneity.
Yes, sir.
Public sector bank, private sector, right?
Yes,
Okay.
sir.
So tomorrow we will work on that, how to work on subsample and how to deal with this problem. Because in this particular data set, we do not have that sort of a variable, right?
Okay, sir.
Sir,
So,
Right? Yeah.
sir, I am still stuck with a question. Same
Which
question.
question? Yeah.
The same question. Sir, actually, when we run the fixed effect within group model, I understand the intercept will show intercept as 0. But I think we can calculate the intercept manually by using the formula of beta 0 as we do in regression.
We can
First
do
one-
it, and
Yeah.
I will show you. It is possible to calculate the individual effect.
Right. Because beta 0 cannot be exactly 0 here.
No, no,
Total
in that, no, 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 no,
average.
no. See, the point is, in the main model, it is not there. But if you want to calculate what are the individual effects,
Right,
that
right.
can be computed. I'll show
Right.
that. I'll show that. There is
Yeah,
code
so
for
because
that.
I
I'll
was
show that.
thinking the average total cost cannot be 0. It is only that the model is removing time in
Yes,
this
yes,
part.
yes. It cannot be 0 because it is the
Right, sir.
main model. It was there, right?
Right,
It
sir.
cannot be 0 because I have just demeaned it and removed it. But that does
Right.
not mean that we cannot calculate or estimate it. We can do
Right.
that,
Right, sir.
right?
Because average total cost cannot be 0.
Yes, yes, yes.
Right.
So I never said that it is 0. What I'm saying that it is not there in this model, after demeaning. That's what.
Right. Right, sir. Right.
Okay. So I think this first point, the problem that I spoke about and how to address that, is that point clear to everyone? Yes or no? By subsample analysis, we can address that issue, right? Is it clear?
Yes, sir. Yes, sir.
Second part, the another disadvantage that this within group estimator is that it removes the long-term effect present in the variable. This is a very important thing, because when you demean a variable, what is left is the short-term fluctuations in the variable. Say, for example, if you think xi, a particular variable xi, say for example, at a particular point in time, or whatever it is, xit, let us say, at a particular point in time. So we can call that as x bar plus some deviation, say u, or error. Correct? Yes or no? Any particular observation can be expressed as a sum of its mean plus some deviation from the mean. Yes or no? Can you say that? Any variable, say any variable x, can be expressed
Yes,
as
yes.
its mean plus some deviation from the mean. We can say that.
Definitely.
Yes.
And if I remove that mean from x, what is left is nothing but the short-term fluctuation. So, say for example, my annual income at a particular point in time is, say, 10 lakh rupees per annum, right? But on an average, or suppose in last 10 years, I have probably, the average return income is, say, 8 lakh rupees, right? So the long-term trend actually is represented by that mean. And if you remove that mean from the data points, what you are actually basically doing, you are removing the long-term effect. What you are left with is the short-term fluctuation. This could be a challenge, because one important aspect of that particular variable is being removed from the model. Is this point clear? Anyone understood, or is it
Yes,
clear
sir.
or not?
Understood, sir.
Okay. So this is another problem. So basically, if you are running a fixed effect model, so basically what you are modeling is the short-term variability in that particular model, because you have demeaned it. And by demeaning, you have removed the long-term effect. So these are the two challenges that we face. And that's why many times we, take help of, ARDL model, where we segregate the short-term effect and long-term effect. And that can be done even in a panel structure also, right? Which we will not be covering in this particular workshop. I'll be doing one more workshop on long panel, where we will discuss the co-integration in panel and ARDL in panel data and all those things, right? So in fixed effect model, basically we are modeling the short-term fluctuations because we are demeaning the variables. I hope this point is clear. Let us proceed. Okay. So now, as someone asked me how to calculate the individual effects in this, see, you can do this. Let me show how to do this in R, calculating the individual effects, right? So this is the code for extracting the individual effects, right? So let me just give you the code. So in the main model, you don't have those intercept terms, but you can calculate them separately using these codes. So let me just give it here. So did I copy it? Control C. and Control G. Okay, so please run the code and see what result you are getting, right? So I'm calculating the individual effects because they are not featuring in the model because of the demeaning I removed them, but we can always calculate them. So let me run this, right? And print individual effects, right? And if you see, these numbers are exactly same as the individual effects we computed under least square dummy variable approach. Yes or no? Can someone confirm? Right? Have you got the output?
So please explain this 1, 2, 3, 4. What is this?
These are, we have that six factors, na? Six companies. So for each company's specific effects. Okay. Some specific effect we computed last class, right?
Yes.
When we did the LSDB model,
Yes.
right?
Yeah.
These are the same numbers that we computed, correct? Is it clear? Yes or no?
Yes,
And
sir.
if you
Yes,
want
sir.
to take, if you want to take them to your CSV, then for that also you can do. But here I would rather prefer to copy and paste them, because to get these 6 numbers I have to write these lengthy codes, right? So if you do cost benefit analysis, it is better to type them individually in the report if you want to. But in research paper, we generally do not report these things, because I told you actually these are nuisance parameters, right? So we know them, that they are present, but their exact impact we are not interested in, right? So in research paper, we do not report them. So that's why I'm not giving too much of emphasis on it, but you can always calculate these things. Should I give these codes to you in the WhatsApp group? Would you like to transfer them to CSV, or we can leave them also, not an issue? Yes, Parminder ma'am, you are asking this only, right? How to compute these things? Yes or no?
Yes, sir. Yes, sir. Yeah.
Yeah. So I think we need not transfer this, because the codes are too lengthy. We can just simply type it if we want to get them in the Excel sheet. Okay. So it's very much possible to calculate them, but the point that I was making, they are not in the part of the main model, because of the demeaning we have removed them. Okay. Is it clear?
Sir, one thing more, I just wanted to myself to be clear about this.
Yes.
I mean, when we remove time invariant thing from the fixed effect model, so time invariant variables are generally long term, and when those variables are being removed from the model, it removes the long term impact. Can I interpret like this also?
That is what I told now. Yeah, right.
Sir, I mean,
Absolutely right.
am I correct on this?
Yes, you are correct.
Okay,
Absolutely.
okay, sir.
That is
Okay.
what was the second point, right? When I
Right.
talked about the
I just
disadvantage.
wanted to be clear about that. Yeah.
Yes, that is correct. Okay, fine. So next, I'm just keeping these two codes, because you can see these are the 6 numbers, and these are same as what we did earlier, right? So effectively speaking, see, in terms of output, we are getting the same thing, but we can get rid of the practical problems of dealing with too many dummies under this approach. That's the main thing, right? Okay. Next, what is the next thing? Let us have the residuals plot, and I'm just giving you this code, and please do the plot and see how it looks like. Please do that, everyone. I'm just giving it here in this. Please do it. Please plot the residual and see what is happening. Everyone, please plot it. I will just do it. Okay. And if you recall, this plot is exactly same as the plot that we got when we ran that least square dummy variable method, right? Yes or no?
Yes, sir.
So basically, we are doing the same thing, but here we do not have to deal with too many dummies in the model, right? Okay, is it clear?
I have a simple question, sir. Like, I am getting confused at when to go for within group, when to go for LSDF.
You should always go for within group. You should not go for LSDB at all.
Okay, sir.
Okay.
Okay, sir. Okay, sir.
Because, see,
Nandi.
LSDB method is practically very difficult to, in research paper, you cannot, report all those things. Correct?
Yes, sir. Yes, sir.
Because-
Yes, sir.
Yeah. And why to go for it? We can get the similar output using this model, right? With less
Yes,
of
sir.
difficulties of reporting too many, what do you call, dummy variables and all those things. And if your data set is smaller, then you might run out of degree of freedom problem, right?
Yes, sir.
So
Yes, sir.
that is another issue. Why to go for it, right? Not required.
Okay,
Correct?
sir. Okay, sir.
So in
Understood.
fact, if you see, that is why fixed effect model is often synonymous to fixed effect within group model. Many
Oh.
people don't even talk about those other models, right? It is
Okay,
as
sir.
this is the model that we do when we talk about fixed effect model, right?
Okay, sir. Understood, sir.
Yeah. Right. So now, so what is the next thing that we will do? We have one more option that is called. Let me go back to the slide. That is called fixed difference estimator. What is this? This is called fixed difference estimator. So we can remove those fixed effects from the model by demeaning it. There is another approach of removing those fixed effects from the model that is called fuzz difference estimator. That means instead of demeaning, we can just take the fuzz difference the way I have explained here. Can you see that what I'm doing here? Delta TC is equal to, delta TC is a function of delta Q, then delta PF and delta LF. Plus the error term is also the difference. Okay. So this is called fuzz difference estimator. In this way also you can get rid of the time invariant component from the model, right? This is another alternative approach. Is it clear?
Yes, sir.
Correct.
Then, sir,
So this is-
here in that case, the intercept will not be there, no, sir?
Obviously it won't be there, right? Because
Okay, sir.
any constant that is there, if you take the
It will be
difference,
zero.
it will be removed, right?
Yes, sir. Yes, sir.
So this is another way of doing it. Now, when to do which method? This question might come. There is no, universally acceptable answer. Again, trial and error approach. But this is again not very frequently used. Mostly we use that within group fixed effect model, right? But this is another alternative approach. Sometimes, if you do not get good result with the other method, you can try it, correct? And that is nothing called right or wrong as such, but we can do it. This is another approach of removing the time invariant factors from the model. Okay, so this is
Sir,
first different estimator. Yeah.
Sir, output with both these method will be different? Coefficients will be different?
Yes. Output will be different.
Okay, sir.
Output will be different because this is a different approach, right?
Right.
Output will be different. Correct?
Okay.
So let me show you the estimation part of this first different estimator. Though initially I did not include this as one of the models, because if you recall, we had 4 models. One was the pooled OLS regression. Second one was the LSDB method. Third one was the fixed effect within group, and fourth one was the random effect model. But this can also be done if required, if you are not happy with the output of the fixed effect within group model, then because this is an alternative way of removing the fixed effect from the model. So you can also try this if this gives you a better result, right? So let me just try that, and I'll show it in the R how it goes about, right? So
subtracting one observation from the other is something like when we take returns.
yes, something of that
Like
sort.
for example of
Or
Nifty.
in time series, many times just to convert a variable into stationary, we take the first difference, right?
Yes,
Similar
yes. Is it
approach.
like that?
Yeah, it is like that. Okay, yeah, first difference. Okay, so many times it is done like that. Is it clear?
Yes, sir.
So, these are two alternative ways of removing the fixed effects, those fixed effects from the model. That's it. Either you demean them or you take the first difference. So both the ways you get rid of them, right? Okay. So let me just give you the codes for this, right? And we will run it. I'll just give you the code from the very beginning to end, so that yeah. Yes, someone rightly pointed that out. Absolutely right. So if there is unit root problem, then we can go for the first difference approach. Yes, correct. But those things we will cover in more detail in when we will discuss in the next workshop, that panel co-integration and things like that. Okay. Right. So let me just give the codes to you, and you can just do it. What is that happening now? Okay, what is it? Okay. Okay. I think this is what someone meant. No, someone wrote something in the chat. That's a valid point. Who was that? Let me just get that. So it is true that the FD model works better than fixed effect within group when the error has a unitary problem. Yeah, maybe. I know at times if you have stationarity is a concern, then we can take a look at this, right? But again, you need to make some adjustment to that. That means, what I mean to say is, you do the first difference and then also you lag them. Then you can get rid of the autocorrelation problem that might be there, because you are taking the difference. I'll just explain this part a little bit. Let us do the estimation part, and then when we talk about the difference or the what do you call, the disadvantage of this model, there I will just explain this point. Is it okay? I do not know what is your name. Is that fine? Who is that? Someone who has written in the chat. Please, if you can speak up. Yeah. Okay. No issues. Let me just do the estimation part, and I'll get back to you and explain this part. Okay. Right. So what happened now? Okay, so you have done this, right? And where is my R now? Okay.
Are we happy with this residual chart now or not?
Now let us see what is coming. I think it will be better than this one, right? Yeah. So first let me run these codes, right? First difference model, right? Summary, print, right? Coefficient. Okay. And residual density, and see, there is still skewed problem is there, but it looks better than the previous one, isn't it? Yes or no? Hello?
See.
Hello? Are you getting the similar plot as mine? Yeah?
Yes, yes.
Yes,
Yes.
sir.
Yes. So this is why you should have every option open, correct? It looks better. Probably with little more modification, you can even improve this, right? Some transformation in the data, even we can improve this. So we'll proceed to the problem with this model. Can I go back to the slide once again? And I will also address the question that was raised. Can I go back? Everyone done with this plotting part?
Yes, sir. Yes, sir.
Yeah.
Go ahead, sir.
Yes. So let me come here. So first difference estimator, we have estimated the numbers, and you see the numbers are different, not same as the fixed effect within group, right? And what are the challenges? Since you look at this term, you have difference, because everything is expressed as a difference. So naturally the error terms are also expressed as a difference. So error term of a particular year is a combination of this year's error term and previous year error term. So because of this, the error terms are likely to be correlated, right? Yes or no? Yes or no?
Yes, sir.
Yes, sir.
Yeah. So this is a challenge. But how do you overcome this challenge? If you model it in such a way that you take first difference, but then after taking the first difference, you lag the independent variables by 1 year, then this autocorrelation problem between the error terms can be addressed. Okay. So probably if we can manage some time, we will explore this option tomorrow when we do the estimation techniques. As robustness test, what I meant by the other day, the sensitivity analysis. That means when you write a research paper, and if you aim for a good journal, say at least ABDC B or above, A, B, A plus, if you aim for those things, if you just give the analysis based on only one econometric method, that's not going to work. So the paper that is about to be accepted is like, there we have robustness test, we have one base model, we have alternative econometric model, we have one alternative measurement model, right? That means one variable is measured using two approaches, and then two econometrics models are used to check the robustness of the base data. So base model. So that's why exploring different models very, very important. That will give you much more credence to your analysis, that your base model results are robust enough. That is what is often called the sensitivity analysis of your result, right? So we'll try and explore that tomorrow. We'll try to use different. We'll have one base model, and then we will try and work out some other econometrics model or some other alternative measurement model to do that sensitivity analysis. Okay. So this first point is clear. Everyone, I think it is understood that it might create autocorrelation problem, and how we can get rid of autocorrelation problem, I just explained. Second, this is a common problem with the fixed effect within group estimator. What is the common problem? That here also, the time invariant variables will be wiped out after first transformation. And in this case also, you can do, if you have any important time invariant variable other than the fixed effect, then you can do subsample analysis and address this issue, right? Is it clear? Everyone understood? Yes or no?
Sir, just have a question.
Yeah.
Sir, when you do a subsample analysis, should the coefficient sign or the values, should it remain the same when compared to the original model which we have done?
See now, a very important question and very good question, in fact. If you are doing subsample analysis as a robust test of your main model, then ideally the sign and statistical significance should be same. Then you can justify that what I am talking about as overall, that holds good in the sample as well, subsample as well, right? Yes or no?
Okay. Yes, sir. Yes, sir. Yeah, correct.
Okay. But, you know, sign may be same, but impact may be different across different sectors, right? Yes or no?
Yes.
So if that can be established, then you say that sectoral heterogeneity is actually impacting your outcome variable, right?
Correct. Correct. Yeah. Yeah.
Right? Does that make sense? I think
Yeah.
that's clear. Yeah.
Yeah.
Okay.
Yeah. Thank you, sir. Thank you.
So many times we use subsample analysis as robustness test of our main model analysis. In that case, definitely your subsample should also, you know, be in sync with your overall model. Then only you can say that your result is robust, right? Okay. Thank you. So this point is clear. Now we move to the random effects model, right? Random effects model. Right? And this model is also known as error component model, right? I'll explain why it is called error component model, and please pay attention to this. This is a little tricky. So consider this model, total cost as a function of all these three variables, plus you have now one intercept that is B1I. So instead of treating B1I as fixed, which we generally do in fixed effect models, we assume that it is a random variable with a mean value of B1. Note that there is no subscript I. The intercept value of the individual company can be expressed like this. That means if I go away from math a little bit and talk in terms of, you know, practical implication of this equation, it is like, suppose you are analyzing bank, right? Every bank is different. There's no doubt about that. But there is some commonality. What is the commonality? Everyone is, say, scheduled commercial bank, right? Yes or no? So if you compare, say, HDFC Bank with ICICI Bank, there will be some heterogeneity. But at the end of the day, both are private sector banks, scheduled commercial bank. So what I'm trying to make you understand that even though individually each company is different, but still they may share some commonality. That is nothing but this beta 1. And what is the total individual effect? That is sum of that beta 1 plus the individual differences that they have. Is this point clear to everyone? Yes or no? Can you say like that? Can we interpret this equation in that way?
Yes, sir.
Does
Yes,
it make
sir.
Can you
sense?
please repeat
Yes.
again? I haven't
Yeah.
understood.
So what I'm saying is, suppose you talk about banks. Each bank is different. There's no doubt about that. But since they are banks, they have something common, right? Yes or no?
Okay.
Yes, sir. Yeah. Yeah.
Yeah. So that is what I'm saying, that the individual company specific effect is sum of one, mean, which is common for all the individuals, plus the slight difference that, one individual is having from another individual. So that is what the intercept for a particular company, this part is the intercept for a particular company, is equal to a common intercept plus some deviation from that intercept. Okay. Is it clear? Understood?
Yes, sir. Yeah.
So where this is constant, but this one is random. This epsilon I is random error with a mean value of 0 and variance of, sigma square, right?
So when you say something is common in those bank, like what?
Something is common in those banks means, see, each bank might be different from each other, but at the end of the day, they are part of the same industry, right? They may be probably all of them may be commercial banks, scheduled commercial banks. So that is the similarity or commonality that they have. Say, for example, if I talk more in specific terms, say for example, you are studying what you call the capital adequacy ratio of different banks, right? So impact of different variables on the capital adequacy ratio. Suppose that is your model, right? But do you know that every bank is required to have a minimum capital adequacy ratio? Yes or no?
Yes.
So you think that as the common part.
Okay.
But every bank is not having the same amount of capital adequacy ratio, right? Yes or no? So you can think this beta 1 as the minimum that is required by the regulator,
Yes.
plus minus something that will give you the capital adequacy ratio of a particular bank. Are you able to make sense out of it, what I just said? Yes or no?
Sir.
Is it clear?
Yes.
Understood?
Yes.
So that is what I mean. I made it more specific, but in generic term, what we can say that each bank may be different from each other, but they may have something common. That common factor is expressed by this beta 1, right? So that common factor plus some deviation makes their individual effect, right? Is it clear?
Yes, sir.
Yeah, okay. So that's what I meant. Now you see, when you say this epsilon I is a random variable, then what you can do, you can add this random variable with its brother. Who is its brother? UIT, because this UIT is also assumed to be random, right? Yes or no? What is this UIT?
Yes, sir.
This
It's random. Yeah, it's
main
one of
error
the
term, that is
assumptions.
by definition is random. And you
Yeah.
are assuming this to be also random, so you can add this to. And if you do that, if you add these two and express them as WIT, then WIT is nothing but the composite error term. Yes or no? Is it clear?
Yes, sir.
Now, once you have added this epsilon I with UIT, correct? You have landed in a problem. What is the problem that you have landed in? You have landed in a problem. What is the problem that you have landed in? Anyone?
One is time dependent, another is time independent.
So because of that, what is the problem? See, the problem is now this composite error term is going to be correlated with the regression.
Exactly.
Yes or no?
Exactly.
Because EI, epsilon I is correlated with all these these regressions, right? Yes or no? And you have taken that and put it into composite error term. Now your composite error term is going to be correlated. And if that is the case, then you cannot run OLS on this for estimating this model. And in that case, you have to use GLS, generalized least square for estimation. That's why for random effects model, you cannot use OLS. The estimation technique is the generalized least square method is used for estimating the equations or the coefficient. Okay, I hope this part is clear. And this is the precise reason why random effects model are called error component model, because you have more than 2 components in your error. And now your error is a composite error term. Okay.
So
Is this
please
clear to
explain
everyone?
composite error once again.
Composite error means composite means what? More than one, right? Added, 2 things are added. See, this is your revised model. This your WIT is the error term, and this WIT is nothing but this epsilon I plus UIT, right?
Yes, sir.
So it is sum of 2 errors, right? Two error terms, and hence it is called composite errors.
Yes, sir.
And this EI epsilon I is likely to be correlated with these regressions, right? Because that is the fixed what you call company specific effects, and company specific effects are going to be correlated with a particular company's output, company's load factor, company's full price purchasing, and all those things, right? So since it is now part of WIT, it is going to be correlated with this, and because of this correlation, your OLS will fail, and we will have to use generalized least square technique. Okay, is it clear now? Everyone understood?
Okay, so you are saying this randomness or error is getting correlated now with the other variables that are mentioned here.
Yes,
So that is where
because you
we
have put them in part as a part of the composite error term. Yeah, clear?
yes.
Okay, fine. So let us now run the regression. That means estimate the error component model, that is also known as the random effect model, and then we will look at it, and we will then evaluate both the models, fixed effect model and random effect model, using Hausman test, and I'll give you some practical inputs on when I can use random effect model and when we cannot use random effect model. So let us first do the clerical part, that is the estimation with the help of the software. Okay, so let us estimate the random effect model, right?
So you are saying LSDV is error sum and then RMB is error sum. So which one is the best? What are we doing then?
I'm coming to that.
Okay.
Let me do the estimation part and then we'll talk about it, right? In fact, if you want to have a very shortcut, answer, fixed effects model, that is fixed effect within group model, is the best model among all these, right?
Yes, sir.
And
I've read papers where we have FEM. I have seen FEM more.
yeah, maybe more, and to be there is a protocol that if you report random effect model, your paper will be DEX rejected. I'll tell you why after doing these estimation techniques, and we will evaluate the model, I will talk about it. Right? Just hold on for some time. Okay.
Yes, sir.
Okay. So let us now do this. I'll give you the codes and then we'll come back to it. Right. Okay, have you got the codes? Yes. Yeah. Just please run the codes quickly, and then I will explain what is the difference in the code that we have made. Everyone, please run the code quickly. Okay, and you see this is worse than the fixed effect model that we did, right? Have you got similar plot as mine?
Yes, sir.
Yeah. Now just take a look at the code that you have done. Everything else is same, right? At least this part I have named it as random effects model, but model is equal to now random. That's it. Okay. So that takes care of the fact that we are using random effect model, right? Okay. Are you getting the same plot? Others, those who are doing it, yes
Sir,
or
I
no?
think you missed one command, sir, while pasting it, that random effect thing. That estimate random effect is missing, sir, in the code which you copied and pasted.
This part?
That was missing, sir. Yeah.
It was not there?
Yes, sir. Yes, sir.
I'll give it once more.
Sure.
Not an issue.
Thank you.
It was there, sir.
It was there, no? I think.
Yes.
Just check. It is there, I think. The
Yes,
very
sir, it
first
was
one is that only, now. Just check once more. The first code is that only, right? This was the code.
Sir, got it, sir. It was my mistake. Yeah. Thank you.
Okay, no issues. So let us come back to it. So now let me go back to explaining how to evaluate which model to go for, and it's going to be a an interesting discussion. Let us proceed towards that, right? And some of you are kind of getting little, what do you call, anxious to know which is the best model, right? Okay, let us get into that. So fixed effect versus random effects model, right? So if you compare the results of fixed effect and random effect regression, you will see that there are substantial difference. Yes, obviously there are differences, right? Now, which one is more reliable, right? So which model we should go for? To decide that, we apply Hausman test, right? So what is this Hausman test? The null hypothesis of Hausman test is that the error correction model or random effect model is preferred over fixed effect model. Or in other words, you can say that null hypothesis is random effects are not correlated with the regressor. This is the null hypothesis. Now, without testing this, you can say that this hypothesis is going to be rejected. Yes or no? Yes or no?
Yes, sir. Yes, sir.
Apply common sense, right?
Yes, sir.
We are saying that E epsilon 1, epsilon I is not correlated with the regressor. They will be correlated. And it is very, very difficult to, hold this assumption in real world. You are saying the individual specific effects, right, are not correlated with the regressor. It is not going to be the case. It is correlated, and that is what is the recognition given in the fixed effect model, and hence fixed effect model is more acceptable because you cannot defend this assumption. You cannot defend this assumption. And in which case you can defend this assumption, I'm coming to that. But for now, let us do the Hausman test and figure out in this context which model is appropriate. And as I just said, even before doing the Hausman test, we can tell that fixed model will be the verdict, right? Because it is very, very difficult to hold this assumption true. Can anyone tell me when this assumption can be defended? That these fixed effects are random, and hence they are not correlated with the regressor. Can anyone tell me before we get into the estimation part? Anyone?
Again, there will be probably homogeneity across these forms. Probably
Okay,
this can be.
Is it the case, or any other points? Any other thoughts on that? Any other points? Anyone would like to throw some light on that? When this randomness assumption can be defended? In most of the cases, we cannot defend it. It depends on sampling. If you choose your sample using random sampling technique, then this model assumption, this assumption can be defended. What I mean by that? Say, for example, in my case, I have taken 27 banks as my sample from India. Is it a random selection? What is your answer? Is it a random selection?
No.
No, sir.
No.
No, sir.
So by default, I cannot use random effect model in this case. Nothing doing. Hausman test, no need to apply Hausman test because my sampling is not random. It is convenient sampling because I have chosen those 27 banks because for those 27 banks, I could fetch ESG data. It is not a random selection. But suppose in world, suppose there are 500 banks. I take all 500 banks and assign random numbers to them. And out of those 500 banks, I take 27 banks. One bank could be from America, one bank from, 2 banks from China, 3 banks from India, 4 banks from Japan, and all those things. Now there is possibility that the individual bank specific effects can be random. Am I
Right.
making sense? Yes
Yes,
or
sir.
no?
Yes,
But
sir.
if I take 27 banks from India and run random effect model, obviously my paper is going to be rejected because I cannot defend that assumption because my sample selection is not random at all. So if your sample selection is not random, your random effect model is straight away out of the question. You do not even have to go for Hofmann test. Hofmann test will always tell that fixed effect model is applicable, right? So even without doing the test, I can conclude that random effect model is not going to be applicable unless you do random sampling. If you do random sampling, then it makes sense to make this comparison or take help of Hofmann test. But in most of the cases, our samples are not random. If that is the case, then anyway, the very first place only random effect model is rejected. Is this point clear to everyone? Yes or no?
Yes, sir.
Yes, sir.
Yes. So that is the funda, and this is the precise reason because of which, if you report a random effect model and if you say that my sample is say 30 banks from this particular sector or 30 companies from this country, then straight away you are out, right? Unless you defend that your sampling was a random sampling, right? Otherwise, there is no way your paper is going to be accepted. It is going to be rejected straight away, right? So we always talk about test, Hofmann test, Hofmann test, Hofmann test. It comes later. First of all, you make sure that your sampling is random. If sampling is random, then only this random effect model comes into picture. If it is not, then it's gone, right? As simple as that. Okay. So let us just do the formality of verifying using the Hofmann test. What does the Hofmann test say? Which model is better, fixed effect model or random effect model?
How to select the samples?
I just said now. Say in that case, you will have to have a universe of bigger sample, and then how do you draw a random sample using random numbers, right?
Yes.
So you select, that's the example I gave. No, so 500 banks you selected across the world. I'm just giving bank example because I mostly work on banks. That's why I'm giving banks example. And then suppose out of that you want to select 50 from 500 you want to select 50 as a random draw, right? Random selection. If that is how you are selecting your model sample, then you can random effect model is very much there in the contention. Otherwise, it is not. The basic point is if your selection is not random, sample selection is not random, then random effect model is straight away out of the question. That's the point. Okay. Is that point clear? If you go back to what I discussed last class when we were talking about the summary, so there it was clearly mentioned in one line that what is this random effect model? See, this is the point I was referring to, right? This is the point, last point. We assume that the intercept values are random drawing from a much bigger population of airlines. If we can justify this assumption, then only random effect model is in the context. Otherwise, it is not, right? So if your sample selection is not random effect model is straight away out of the question. That's it. Nothing doing. Okay. So let us now do the Hofmann test to complete the formalities. Right? Everyone is kind of convinced with this explanation. Yes or no? Any doubt on this?
Yes, sir.
Okay. So this is what is.
Sir, just to have more clarification, let's say
Yes.
I'm selecting some stocks, and these stocks, if I'm selecting from a similar sector, right? So it can, in that case, random effect might not give good results.
Yeah, it is rejected straight
But
away.
if
Suppose
I'm
all the banks are from same industry, same
right,
sector.
right. And if
So
I'm
random
selecting,
effect you cannot apply.
right,
But suppose you take a sample of 500 stocks in Nifty 500.
right,
Out of that, you use random sampling technique and choose say 30 companies.
30 companies, right?
Then the possibility of applying random effect model is there.
Yes, sir. Yes, sir. Right. Exactly.
And otherwise, it is not. Suppose you take all the companies from you are studying say IT sector.
Right.
Right.
If I'm studying a particular
So
sector,
it is not a random selection. right?
sir.
So
Right.
can you apply random effect model? Answer is no.
No.
Forget about Hofmann test. You
Right.
cannot even apply random effect model. As
Perfect.
simple as that,
Perfect.
right? And this is why, you know, many people complain, oh my God, my paper is rejected. They did not even look into it. They will not look into it.
But sir, in this case, when we are selecting the companies out of 500 companies, and then in that case, Hosman test gives some justification that random effect model is better in that case.
Then you can do it, because that's what I'm saying. The first point is you have to defend that your sample was a random sample.
I'm just talking about the rejection of the paper, that in that case, we can justify that random.
Yeah. You can. So first of all, you have to ensure that your sample selection is random. Then only you can go for random effect, right? If at all it is right. Okay. See, the point is random effect model as a concept is very, very sound, but it is difficult to defend that assumption, right? So that's the problem. And in most of the cases, we go for convenience sampling. I take the sample as per availability of data, right? So very first place only I'm going to get rejected on random effect model. Okay, so I hope this point is clear to everyone. Yes or no? Yeah, clear? The verdict is clear
Yes,
to
sir.
everyone?
Yes,
Yeah?
sir.
Yeah, good. So now, from now onwards, you need not worry about this random effect model. And it is not an exaggeration that even without doing Hofmann test, in all my papers that I have written so far, I have used fixed effects model, and we do not even report Hofmann test because it's not required. Once your sample is not a random selection, it is only fixed effects model. Random effect model is out of context. You do not even have to report it. You look at good research papers who have used fixed effect model, they don't even report the Hofmann test, because it is by default it is accepted that it is it is going to be fixed effect model. Random effect model cannot be defended, right? So only when you have a sample selection based on random sampling technique, then only you go for even testing whether random effect model, fixed effect model is appropriate. Okay, I hope this point is loud and clear, because this is one of the areas where most of us are kind of little confused and what to do, what not to do. Clear, no? Any other points anyone would like to discuss on this? No? Pretty much clear? Yes or no?
Yes, sir.
Yeah. Okay, so let us go ahead and do the coding now. Just a formality for Hofmann test. Okay, so I'll just give you the codes for Hofmann test. Codes for Hofmann test, right? Right. Okay. So do that. Let me. Have you got the codes, please? We have run this. Okay. Now tell me, what is the result you are getting? Null hypothesis is rejected, right? Yes or no?
Yes, sir, it is rejected, sir.
So this 3.832 e to the power of minus 13 means what? It is 3.832 divided by 10 to the power of 13. So it is 0, right? Yes or no? So null hypothesis is rejected. So null hypothesis is rejected means what? Fixed effect model, right? So, invariably you will find that your null hypothesis is rejected if your sample is not a random sample, right? Is this clear to all of you? Yes or no?
Yes, sir.
Yeah. So I think that debate on fixed versus random is sorted once for all, right? I think from now onwards, you should not have, that confusion, what to do, what not to do. Just Hosman test is just a formality if your sample is not sent, right? Random. Okay. I hope this is clear to everyone. Is it clear? Yes or no? So let us now just formally conclude this topic on fixed versus random effects, some guidelines. And then we will do some modification to our model and see if we can get some better results. And next class, we will dive deeper into a bigger data set, which is like, we will look into some research paper, which you also can replicate similar work if you want. So that we'll do tomorrow. So fixed effect versus random effects model, some guidelines. Which one is better? Answer to this question hinges around the assumption we make about the likely correlation between individual cross-section specific error component EI and X regressors. This is the point I was making, right? And if your sample is not a random selection, then this epsilon I and regressors are more likely to be correlated, right? And if it is assumed that EI and the regressors are uncorrelated, ECM may be appropriate. Whereas if the epsilon I and the other regressors are correlated, fixed effect model may be appropriate. And that is the precise reason why always we go for fixed effect model, even without going for the test. So the assumption underlying ECM is that EI, epsilon I, these are actually random drawings from a much larger population, right? But sometimes this may not be so. In fact, most of the times, at least in India, we have challenge with respect to data, right? See, if you look at good paper, probably their sample size is 500, 300. Even though they are working on banks, their sample size is 347. And here in India, we are struggling with 27, 30 banks, right? And we are at the back foot simply because we don't have enough data. Because most of these, models are asymptotically efficient. What does that mean? Asymptotically efficient. This point I will emphasize more when we'll be discussing the system GMM and things like that. That means, for larger data sets, what is asymptotic property? Those who are from econometrics or statistics background, anyone? Asymptotic property, what is that? That means,
the positive and the effect of the positive and negative values are not same. When we say particularly in stock
no,
market.
that is asymmetric. That is asymmetric. I'm
So
talking
sorry, you are
about
Randomness.
That means it is for a large sample, you may have this property, correct? So when you work on a very, very small samples, you are already at the back, correct? I have given one example here. For example, suppose you want to study the crime rate across 28 states in India. Obviously, in this case, the assumption that 28 states are a random sample is not tenable, right? You are studying India, you have taken all 28 states. Is your sample a random selection? No. And how come you expect that, the individual specific components of each state will not impact the outcome of that particular state's variable? It is going to impact. So it's very, very difficult to defend that assumption. Okay. Is it clear? Understood? Yes or no? Understood? Yeah, this point is clear.
Yes, sir.
Yeah. So let me go back to
Hosman test says to choose FEM, and then after that, within group or first difference, how do we select that? What to do there?
That is what. So in our first preference will be fixed effect within group. Okay.
Okay.
Unless you have some other, probably as a robustness test, you can also try pulse difference model. Your base model should be fixed effect within group. Okay, that is the most acceptable from my own experience. I'm saying that's the most acceptable thing if you are working on static panel data, right? And sometimes we have this notion that static models are inferior than dynamic models, right? That's not the case. Anyone knows what is the basic difference between a static model, static panel data model, and a dynamic panel data model? Anyway, we'll talk about it later on. But just
Lags
to
of lags.
yes,
When lag values of the independent variables are included.
independent variable or dependent variable?
Dependent variable, sir.
Dependent variable.
So dependent variable. Now I'll share one experience. One of my papers is under review in second revision in IIM Bangalore's management review paper, right? So it's been almost 1.5 years. Probably next year, sometime in January, it will be published. Now, I got one of the comments from one of the reviewer that in one sentence I wrote that dynamic models are superior than static models because it captures the dynamism in the dependent variable, right? Then the reviewer came back saying that this is a false claim. How can you justify that? Can we claim that one variable is explained by its lag, and because of this fact, it is a superior model? In that case, you are undermining all the theories. He was pretty right, no? That means, if that is the case, if a variable is only, kind of explained by its lag value, then what about the theories that we talk about, right? So in theories, we talk about relationship between different variables, no? If one variable can be explained only by its lag, and if you, because of that, if you think that this is a superior model, then what is the point of having any economic theory for that matter? So I had to kind of, rewrite that part, correct, and respond to the reviewer. So it's not that static models are not good, and if you work on static models, that your paper will not be published. Only thing is, you have to ensure that your model diagnostic tests are, favorable. That means you can defend the assumptions of the models. If you do that, you can, even with simple, static panel data model, you can publish in good chance, right? And dynamic model, definitely it adds to your possibilities, provided you work on a bigger sample, right? So next class we will delve little deeper into how to do the analysis and how to approach a research paper based on static panel data technique. Okay, is it clear? Right. So let me just do a little bit of improvement in this model. So to go for model is basically the fixed effect within group model. And as I showed you last class, that if we do a log transformation in this particular case, things will improve. On top of it, I will also include one more component, that is robust standard error today. And we will do the remaining diagnostics in the next class. Okay, so we'll introduce one more concept of robust standard error today. Okay. So let us do the log transformation and redo the fixed effect model, but we will be using two-way fixed effect model, not one-way fixed effect model, right? So let us do it. Let me give you the codes. Are you ready? Can I just give you the codes, and then we can think about it. So I'm just giving you the codes, and then we will talk about the standard, robust standard errors. Okay. And we'll conclude today's discussion. Okay, everyone, please do the coding part quickly, and then we come to. Are you able to do it? Class is getting silent. What? Yes. Have you got the codes? Yes or no?
Yes, sir, up to it, sir.
Yeah. Please do it quickly.
Sir, model is better now.
Yes, model is better. Just run the codes, everyone, those who are doing it, and see what is happening. Coefficient summary, right? Yeah. Okay. And so you can see that it looks much better now with log transformation. It looks much better. But this is also, subject to further tests. In a research paper, by default, you have to do one thing. That is, you have to ensure that your standard errors are robust standard error, right? Till now, I have not talked about robust standard error. What is meant by robust standard error? Anyone can throw some light on it? Anyone? Have you heard of it? Robust standard error?
Yes, sir.
What
So
is it? What purpose does it serve, and why we always talk about robust standard error? For that, for your understanding purpose, first let us understand what is standard error and how important it is. Why standard error is so important, and anyone? Why standard error is important?
Heteroscedasticity, sir.
First of all, you would like your standard error to be lower or higher?
Lower.
Lower.
Because lower the standard error, more accurate
The model is.
sample estimates are going to be to the population parameters, right? Yes or no? That's the basic funda, correct?
Yes, sir.
Yeah. So you would like to have lower standard error. But when we do the basic standard error calculation, we average out the standard errors, right? Because what we report is the average standard error. But
Right.
effectively speaking, in a data, the variability might differ across different levels of that particular variable, right?
Yeah.
And if you just simply average out the variability, then you tend to, underestimate or overestimate the errors, correct? Yes or no? And that might create a problem in your hypothesis testing part, because if you recall, your p-values are computed using standard error, right? Your confidence intervals are also computed using standard error. And because if your standard errors are inaccurately computed or it is averaged out, you might end up rejecting something which should be accepted, or you might end up accepting something which could be rejected or should be rejected, right? So this would create a problem, right? So what we do, we use robust standard error. What is robust standard error? It means you are not averaging it out. It's not a simple average anymore. It is weighted average. That means where you need to give more weight, you give more weight to the variability, and make sure that your variance estimates or your standard error are close to reality, right? If this is done, then this takes care of heteroscedasticity problem to some extent. And also it takes care of a little bit of autocorrelation problem. So by default, when we report fixed effect model within group model, we use, I'm talking about good research paper, that robust standard error. And after doing that, we talk about the diagnostic test. Okay. So let me do it. We'll just take the help of robust standard error, and we will just get the things right. So how to do it? Or for robust standard error, so I have the codes with you, and then we will look into these codes. Correct?
So I have
And
doubts.
yeah, tell.
So can you please go back to those logs, plot logs?
This one, this is well.
Anji. So here we are working on, what are we doing here? We are doing a two-way FEM.
Yeah. I'll just tell these codes. Yeah, this is a quick. Now, see, when we do two-way fixed effect model for this within group model, what we are doing basically, you see, these codes are this part log of C is your dependent variable, and these are all your independent variable log version. Data is equal to P data, right? And model is within, and effect is two ways. This component was not there earlier, right?
Yes.
Yes or no?
And whenever we do two-way FEM, we have to first make logs.
Not necessarily. You can do it in without log also. You can do it. That's not a problem. But as I know for a fact that, because in last class also we did it now, in when we applied the log and took the time effects also into consideration, then it improved our model, right? That is why we have done it. But ideally, you could have done it even for without log also. And if you try that, it will not improve the model much, because it was tried last class itself, right? So here, what we have done basically, we have first converted the variables into its log version, and then we have applied a two-way model, two-ways model. So if you are applying two-ways model, then effect should be equal to two ways. If you see, this component was not there when we run the fixed effect within group model earlier, right? Is it clear now?
Yes, sir. And what we did earlier, FEM within.
That was one-way model, one-way fixed effect model.
Okay, and this one is a better and improved version of that.
Yes.
Okay.
Because log transformation improved the what you call the linearity part, and even two-way impacts also improved my model, and because of this, my error term looks much more normally behaved, right? Okay.
So
Is it
then
clear?
we have to make a choice then we have to make a choice that I have to choose whether within FEM or two-way, right?
Whether one-way FEM or two-way FEM. Yeah.
Okay.
So this should always be tried before you come up with your final model, right? Whether two-way fixed model effect model is giving you better result or not. There is no guarantee that,
my
but you should
residual
always
chart.
try. Yeah.
And
Okay.
that I can check with my residual graph.
Yeah.
Okay.
Residual graph, plus you have to also go for additional diagnostic test, which we'll discuss tomorrow, right? Okay. Because you have to check the heteroscedasticity, you have to check the autocorrelation, you have to check the whether cross-sectional dependence is there, whether other things like whether the model specification error is there, that is orbital variable as is there or not, all those things. But at least you have to ensure that if you cannot meet all the assumptions, at least you have to use robust standard error that takes care of your heteroscedasticity, and also at least you have to ensure that your autocorrelation problem is not an issue, right? At least these two you have to ensure to be able to publish in good journal, right? So we'll talk about it in tomorrow class, but let us just introduce this robust standard error thing, right? Which I just told you that in robust standard error, we give different weights to different levels of variability. We do not average it up, right? So that's the basic idea behind robust standard error. Okay. So let me just do this. I'll share the codes with you, and then we will look at the things, right? Okay. I'm just giving you the codes. Please work on it. Was running the code. That is LM test, right?
Yes, sir.
T-
TEST.
Okay, so we already have this LM test, this thing, right? Installed earlier, right? Yeah, correctly. Fine. Okay, so it has given me the output, right? So please run the library LM test, because LM test we installed previously, right? So no need to install it again, just load the library, okay? And then run the command. Ideally, I should put this here. Somehow I missed it. First, we load the LM test, right? Are you able to do it now? Yes, everyone? Just load the LM test, library LM test. Yes, everyone is getting it? First, you run these codes. Those codes are for taking the coefficients.
Done, sir. Done.
Okay. Are you getting the answer? Yeah, output is coming. Yes or no?
Yes, sir.
Yeah. Okay. So now look at the estimates. If you look at the estimates, now out of 3 variables, only 1 variable is statistically significant, right? Yes or no? Till now, we are getting almost everything statistically significant in the model itself, and then we were worried about this thing. But in this model, when we are using robust standard error in this model, you are having only when you taking heteroscedasticity into consideration, you are having only 1 variable as statistically significant, only this one. Only output is statistically significant. Then your PF and LF, these two are not statistically significant. Are you everyone getting the same result? Yes or no?
Yes, sir.
Yeah. So that's why another important aspect in good research paper is, if you have everything statistically significant, they doubt your result, right? Because ideally you won't get that kind of a situation, right? Because everything is statistically significant. Till now we were getting everything is statistically significant, that too highly significant, not even at 5%, it is at even at 0.1% also it is statistically significant, right? So these are some of the things that we need to look into when we work in a research paper. Okay, and then if you want to just take these outputs into the what do you call Excel sheet, then you can use these commands also. Would you like to try? I'll just give it and see whether it is working or not. It should work. If it is not working, not an issue, because we have got the output.
So only one variable is significant. What do we make out of it?
It's very simple that only just let me go back to the thing. We are only saying that only output is significantly impacting the cost, right? This is what it means, because if something is now, this is an important aspect that I need to explain. Can anyone tell me what does statistical significance mean? Anyone? When he says this coefficient is statistically significant, what does that particular thing mean? Anyone?
That means that independent variable is impacting our dependent variable. So that is significant in explaining the dependent variable.
If you have to explain some layman, what is statistical significance? How do you go about explaining it? Anyone? It basically means what?
So that variable, that independent variable is explaining our dependent variable. So,
So it basically means it is not a fluke. That means this, relationship that you have got is not by chance. That means if you repeat this exercise several times, you are going to get similar result. This is what it means in simple words, right? So statistical significance means this relationship is not obtained by chance, right? And if it is not significant, then you have doubt that it would be by chance, right? That's the basic crux of it. And because something is statistically insignificant, I need not report it. When you write the research paper, if your coefficient is statistically insignificant, you need not report it at all. You should not, report it means you need not interpret it, because it could be by chance. And if it is statistically significant, then it is not by chance. That means that is going to be accepted as a valid statistical relationship. This is what it basically means. So if you get the result like this, then when you write it in the research paper, you will definitely report all these things, estimates, and I'll show you how to report. We do not write like this. We just mention the standard estimated coefficient, and in bracket we give the star to denote whether it is significant at 1% level, 5% level, or 10% level. So in this case, when you interpret the impact of the independent variable on the dependent variable, you will only talk about Q, log of Q, not these two. Okay. And you see, when you use this robust standard error, your statistical significance, that means you will not have everything statistically significant. So this is much reliable result. That means you can defend this sort of result. So whenever you have all the variables significant, they doubt that there is some possibility of spurious correlation or spurious regression. So that is why most of the times we emphasize that you use robust standard.